Maybe we can wait for a couple of more minutes before we get started. Yes, we can get started. Thank you everyone for joining this community call. We are looking forward to it. Before we get started, we can go through a few housekeeping items. So you can use the chat area to post your questions, or you can also do live Q and A. And before we get into Q and A, we can quickly walk through what actually happened in the incident and give you a quick overview of that. And then after that, we can open up for Q and A. So with that, and for the benefit of the community, this call is also being recorded, and we will post it online, after the call is over. So let me go ahead and share my screen, and we can quickly walk through, what happened in this incident. And yeah, please feel free to use the chat area if you have any questions, and we'll try to answer them. Um, um, Whenever possible. So this TJ action slash change file actions is a very popular action, and it's being used by more than 23,000 public open source repositories. In addition, a large number of enterprises also use this action in their private repositories. So, in this incident, what happened was a bad actor got access to this change files repository, and on Friday, they pushed a malicious commit in their fork, and then they updated all the existing release tags for this action to point to their malicious commit. So, if you look at uh, release tags that are available in the repository, right now, they are actually pointing to the correct location. But during the incident, what had happened was the adversary had updated all the release tags to point to this malicious commit, and we'll actually talk about this malicious commit in a minute. Because of which, if you were using this action, either by referencing this particular tag, or if you had pinned this action to a specific commit, but your reference was upgraded to use the malicious commit, it ended up executing the malicious code in your CI/CD environment. And we are going to cover, what this code did in a minute. So, but if you had pinned this action to a commit other than this malicious commit, you did not actually execute the malicious code, during this incident. So let me actually walk you through, this malicious code, and I believe this reference has been deleted. So maybe we can look at the screenshot that we added in our blog. to see what was happening in the incident. So as you can see, this malicious commit directly modified the dist file, right? Do we have any questions? Sorry. Okay, I'll continue. So as you can see, this malicious commit directly modified this dist file, and it added this malicious code, which is which is base64 encoded. And if you decode this, right, so it actually, you can see that it's downloading this memory dump.py Python script, and then it's running that Python script. And we'll cover this Python script in a moment. But what it's doing is that this Python script, it takes the output, it actually grabs through the output of that script, and then it base 64 encodes it twice, right? And then after that, it's printing the finding. So during this incident, the stolen credentials were not exfiltrated to a remote endpoint, but they were actually printed in the GitHub Action workflow logs. So if you look at the script, what the script is doing, I think this script has also been removed, but we have a snapshot of that. Yeah, it has been removed, but we have a snapshot of that in our blog. So as you can see, this script is first is looking for this runner worker process, and once it finds the runner worker process, it actually dumps all the GitHub Action workflow secrets from memory, and it prints it. And then over here, as you can see, we are grepping through it, where it does a particular regex search, and then for all the matches, it's again it base 64 encodes it twice, and then it prints it in the log file. And if you look at the commit, um, based on the author, the commit is saying it came from Renovate bot, but it's actually not true. The adversary had spoofed this name to sort of like hide their track. This commit did not come from Renovate, but this was done to like create confusion. So let's actually uh, so that's a quick overview of like what happened in the incident. And currently the repository, which is the original repository, is back online, and it has been updated to remove the malicious reference. So it's not malicious anymore, and all the tags are actually pointing to their previous commits. So it's safe to use now. Next, we can quickly look at how we detected this incident. So StepSecurity has a product called Hardened Runner, which is a purpose-built CI/CD security agent. So you can think of this agent like, you have EDR solutions for your desktops and laptops and for your cloud instances. Similarly, we have built a purpose-built EDR, or endpoint detection and response agent, for CI/CD runners, and it's based on our learnings from previous CI/CD security attacks. So we looked at all the previous CI/CD security attacks. We figured out what went wrong, and then we created security controls to either prevent them or detect them. And then we then implemented these security controls into our Hardened Runner solution. So Hardened Runner community tier is free for open source, and it's currently being used by more than 5,000, or rather 5,600 open source projects. In addition, Hardened Runner is also available for private repositories and self-hosted runners. So in this case, what had happened was, so CI/CD jobs are fundamentally different from a typical cloud workload, or typical say laptop, because unlike cloud workloads, CI/CD jobs are very predictable, because they do same thing again and again. They download the source code from a well-known location. They create software builds, and then they publish these software builds to another well-known location. They download dependencies from a well-known location. So what Hardened Runner does is, it actually observes a given uh, CI/CD job across multiple runs, and then based on those findings, it creates a baseline. So for example, for this particular, so for this particular job, for example, we can see that hardened runner has observed 123 job runs, and then based on that, it has created this baseline. So let me actually go back, and we can see an interactive demo of how hardened runner actually detected this attack. So in this case, this is a demo workflow that we have created to simulate the attack. And as you can see, it's using the compromised version of TJ action slash change files action. And in addition, it's also using hardened runner. And then what you see on this screen is the insights page for this particular workflow run, where the exploit code was triggered and it downloaded the malicious Python code, and it executed it. So in the summary tab, we can see that in this run, two network outbound destinations were observed, github.com, which is expected. But then we also observed gist.githubusercontent.com, which was flagged as anomalous based on the baseline that was created for this particular job. And then we can click here in the jobs column to see runtime insights for this particular job, to figure out more details about this particular call. So you can see that this particular call and what hardened runner does, the one of the key differentiators for hardened runner is that it correlates all the runtime events back to the exact CI/CD step that caused it, right? So in this case, we can see that gist.githubusercontent.com call was actually made by the TJ action slash change files action, and it was made through a process called curl, and we can see the process ID as well. So now we can click on this, and you can see that again, we can see that this endpoint is flagged as anomalous. So now we can click on this process ID to see the process tree and process argument. So as you can see, in this case, curl was called to download this malicious Python script that dumps memory from the runner worker process to steal CI/CD secrets. And this is actually what you see in this. I think it's part of the blog, but so this is the same curl command that was actually added in the malicious commit. And any questions so far? I'm not monitoring chat, so please let me know
Hey,
if we should
Ashish.
start.
Yes,
Yeah, Jason.
Jason here. Real quick, and you may have mentioned it in the blog. Um, how did can you walk us through like how did the actor how did he allowed to contribute? Did he fork the repo and then he made something like, hey, I got an update, or did something kind of slick to allow the maintainer to approve it? Could you kind of go through that?
Yeah, so I think it's mentioned in this issue, and the maintainer has actually provided a brief summary of what happened.
Oh, okay.
So based on the comment from the maintainer, what had happened was this bad actor had gotten access to a pat that belonged to a bot account that this maintainer uses for automation, and this bot account was allowed to update tags. So in this case, what had happened was this malicious commit that you see here, right? This
Uh-huh.
commit is actually not part of the official TJ Actions change files repository. So what this bad actor did was they created a fork of the repository, and then they introduced a malicious commit in their fork. But the way GitHub works, you can actually reference commits from a fork in the base repository. So the malicious commit existed in the fork, but the bad actor, because they had access to this pat, they updated all the release tags to point to their malicious commit, which was actually in their fork. But it doesn't
And
matter, because when the tag was executed, it actually downloaded code from the malicious commit, and it appeared as if the code belonged to the official repository.
And that was based on the bot that was already being used from the TJ Actions, that Renovate
I
bot potentially.
No, so that was a separate bot. I think it's mentioned in one of the comments, but it's not the Renovate bot. This Renovate bot, what you can do essentially, when you create a commit, and it's actually very weird behavior by GitHub. You can actually specify the user, and
Oh yeah.
so you can actually specify whoever you want. And the way to validate, whether the user is who they say they are, is to actually look at the commit signing. If the commit is signed, that
Uh,
means the name that you are seeing is sort of validated. But in this case, this commit is not signed. And the bad actor just specified that this commit is coming from Renovate bot. It's actually not. Renovate had nothing to do with this incident. So the bot account that got compromised was a separate bot account that this maintainer has for automation. It's not this bot account that you see in this screenshot.
would that indicate as well that the TJ Actions change files is part of their security of the repo? They don't have it being required to be a signed commit, right?
Yeah, that's correct. You
Okay.
can, if you look at
So
the
this
commit
this is a
history.
good example of why that's important for a security check to make sure that your committers are signed users.
Exactly. Yeah.
This is a perfect
Exactly.
example for that. Okay,
Yeah.
I
Yeah,
see.
yeah, you summarize it well. I mean, that is the purpose of this verified tag, so that you can verify this commit indeed came from, this author, and it's not like someone is trying to uh, impersonate them.
Is there any way to know if they have fixed the problem that allowed that user to point everything at the bad commit in that repo, or is that repo still potentially compromised?
So, um, Varun, please correct me if I'm wrong. So in this case, the pad that was stolen has been revoked,
Okay.
but I'm not sure if the maintainer has specified how that pad was stolen in the first place.
Are you
So
saying
Right.
I'm not sure
path?
if you know. Sorry,
Are you saying
PAT, personal
path?
access token. Personal access token.
Oh,
PAT.
personal access token. Okay.
Yeah.
Personal access token of that repository was compromised. Is that right?
Yeah. So
Yeah, of the
essentially, this. Go ahead, Varun.
yes, yeah, the personal access token of the bot account. So there is a bot account which has access to that repository, and the
Uh,
personal access token of that bot account was compromised as per the author of the action. That's what they mentioned in one of
right.
the
Okay.
issues. And now, for the other question, like this is something that a lot of other people are also asking in the in the issue in this repository is like how did that personal access token got compromised? And if it's not clear how it got compromised, then can it get compromised again? And to that, we don't have the clear answer of exactly how it got compromised. And but for that reason, it's not clear if it could what was that exact method used to compromise it? And, if it's not clear what was it, could it happen again? So that's something we don't really have an answer to. But what we know is that as per the maintainer of this action, there was a bot account, uh, and the personal access token for that had been compromised, and they have, revoked it and rotated it. But it's not clear how it got compromised in the first place.
Are we
So
in the Q&A session already? Or do you want to continue the walkthrough?
We
I
can
think
quickly cover. I think we only have one more section, right? The recovery steps.
yeah.
Yeah, we can
My
quickly
question would
cover
be,
them.
yeah, my question would be tied to the recovery aspect. So if you will allow me to just quickly ask it, I think it ties nicely into it. So um, our question is, we've discussed the incident in our company here in Norway this morning. Is the StepSecurity action that you've just published, is that a fork of TJ Actions and you were completely diverging from the original open source code, or are you mirroring it with some extra steps added along the way?
So, to answer your question, we have an enterprise offering called Step Security Maintained Actions. And what we do is, we have a scoring system, and we objectively rate different actions on several, security best practices. And then the actions that have low scores, our enterprise customers can request that, we create a copy of it, and then we bring it on par with the recommended, security requirements. So what we do is, we take the action. So we create a copy of it. Then we run security tools on these actions. We do a manual code review. We discover, and we have a set of security best practices that we follow for all of our maintained actions. We implement, missing security controls, and then we follow a secure release pipeline to release them, and then we maintain them in good standing going forward. So to answer your question, it's actually sort of both. So as new functionalities get added, in the upstream repository, we periodically bring them into our copy as well. In addition, we, like I mentioned, we continue to maintain these actions in good standing, right? So we keep on updating dependencies. We keep on making changes that may not exist in the upstream repository.
So basically, do I understand correctly that you diverge significantly from the original source code in your fork?
Not necessarily. So we don't diverge in terms of functionality, but
Mm-hmm.
if we have to make changes to make sure that we are maintaining the security bar, that's where divergence is possible. But we don't diverge in terms of the actual core functionality of the action.
The reason why I'm asking is, do we need to migrate to yours, or can we stay on TJ? And if the development of the two actions is independent, then of course there's going to be a delta or a lead time between features introduced in TJ and available in your source code. So do you have any kind of estimate on that, on how long does it take to get up to feature parity with the original OSS code?
Yeah, so with respect to the decision on whether you should use the original one or whether you want to use the step security change files, that's I would say it's just a decision for each organization to take. What we can say is that we will maintain this action actively, and this we apply as part of our uh, enterprise offering, and this one is going to be free for everyone because we wanted to make it available quickly for the community. But we apply security best practices and stuff. But that ultimate decision whether you want to use the original or whether you want to use this one, we don't want to necessarily um, point to ours, but that's a decision each organization can take based on this data. For the second question, about the timelines when we pull from upstream. So we have a process, and essentially it's not immediate, right? So it's not that immediately as soon as a release is made in the upstream that it would come in here. Now we have a team dedicated that, and some automation that looks at that there's a new release or changes in upstream, then they're brought in. We do a manual code review to make sure everything is okay, and then it gets merged, and then a release is created. So typically this takes that there's you can imagine the typical 2 weeks to a month lag between a new release and upstream versus ours, and that is to make sure that we are doing a security review and make sure that it doesn't it's not malicious and so on.
But do I understand correctly? And by the way, I'm not asking you to tell me to use your action or the other one. I'm just trying to make an educated decision here. But does that mean that you guarantee feature parity between the two code bases, basically, moving forward?
Yeah. Yeah, and these are so essentially you can think of this as a secure drop-in replacement. So we try to
Yeah.
match the tag, and
Hmm.
we don't add functionality ourselves. Our goal is really to make sure that it is a secure alternative and that it doesn't have different functionality. So it's just drop-in replacement.
Hmm. And just to clarify, but I think I know the answer, there is no like breaking changes or anything introduced where we need to change our workflows for parameters passed to the action or whatsoever, and there's
Yeah.
nothing planned along those lines either.
No. There's no breaking change or nothing, and that was never our goal of doing that, with maintained actions, just to offer a secure drop-in replacement. Uh, yeah, and when we patch dependencies, those are released as a patched version update.
Thank you.
Thank you for these great questions. So yeah, we can quickly walk through the recovery steps, and I think you have already covered this one. So we released this action when the attack was sort of like active, and at one point this repository itself was unavailable. So we wanted to actually make sure that the community has an alternate version that they can use, and this action is free for everyone. The second step is you should because you might have leaked secrets in build logs during this incident. You should review your actions inventory, and you should figure out all the workflows in which this action is being used, which we are going to use in the next step. And one simple way to do that is to actually use a GitHub search URL. So we've given a sample search URL that actually shows all the repositories in the actions organization that are using this change files action. And once you have the inventory, then you should look at past workflow runs during the incident period, and see if you have leak secrets. And we have given an example how it looks like. So it shows up under this change files section, and it's uh, double base 64 encoded string. And if you have any leak secrets, you should rotate them immediately. If you have any long, like a persistent leak secret, you should rotate them. As you may know, all the workflows have a default secret called GitHub token, which I believe is active for 24 hours. So if the leak happened, say beyond 24 hours, then the secret shouldn't be active anymore. But we still recommend you delete these workflow runs specifically for public repositories, because these log files are accessible to everyone for open source repositories.
Which
And
is
even for sorry.
no, go ahead. That's just
Yeah, and even for private repositories, we recommend that you follow these recovery steps, because organizations typically don't have access control for workflow logs. So if you have exposed a sensitive secret, it may be available to everyone within your organization.
so. I was just going to ask you. It's just so even in obviously public repositories are more susceptible, but private ones follow the same pattern as you would anywhere, obviously. But
Yeah.
the best way to find those is um, eh, at the org level. I guess it wouldn't be in the audit logs specifically; it'd be in the workflow run logs, right? So you need to find out
Yeah.
where it was run and then go to those specific actions to see if it was revealed in that log. Is that right? Or is there another way of finding that?
Yeah, that's correct. So you get the inventory of all the workflows that use that action, and then you look at all the workflow runs for those workflows during the incident period, and then for each workflow run, then you look at the workflow logs to see if you have leaked credentials or not. Yeah,
Okay.
it won't show up in audit logs. The
Yeah, I
only
didn't think
way to
so.
figure you have to look at the workflow run logs.
Okay, perfect. Thank you.
Ashish, we've got a couple interesting questions over in the chat. One of them that I didn't see covered in the article from Steve over here says that we're asking if you know what the incident dates are. Do we know when this actually first appeared? Because the original commit got deleted, so we're not really sure when that happened.
So yeah, so we have actually mentioned this date based on our analysis. Our analysis was started on March 14th
Hmm.
at 4 p.m. UTC.
And that was actually when that tag change was made.
Yeah, I think this is when the commit was made. So this is based on
Okay,
the commit timestamp.
cool. The other interesting question that came up from Claire here is that since it was pulling in from a gist, the gist history can be rewritten, and we don't know what that gist may have looked like at the time, or if it had changed at any point in time. What are your thoughts on that one?
That is correct, and it's unfortunate that the gist is no longer available. But we did look at the gist history manually, and it's not covered in our blog. And I think the last changed timestamp was 2 years ago.
Okay.
So I don't think the gist was changed during the incident. But yeah, that is technically possible. But in this case, it looks like that didn't happen.
Yeah, it's
Good. Yeah,
also
I
important
think
to
the big concern there was that yeah, they could have changed it and then actually exfiltrated some of the secrets and not just poured them out in the logs. So okay, cool. Thank you.
yeah, it's also important to note that this gist was actually published by a security researcher long back, and the attacker in this case just reused that gist. So the gist that was being used, was from a security researcher, and I mean, um, so unless they were
Yeah.
involved with this incident, which is unlikely. Uh, yeah. So
Yeah.
and was it also tagged by commit? Ashish, looks like in the
Yeah.
in the code it
You're
may have
right.
been tagged by commit, so it could not have been changed during the
Cool.
incident.
Cool. That's
Okay.
a little relieving. Thank you.
Yeah. No, these are great questions. And then the last part is, for our enterprise customers, we have provided instructions as to how to use our platform to perform, some of the steps I covered earlier. So we actually, so let me start with the inventory one to actually go in the same order. So in our platform, you can actually see an inventory of all the actions that are in use, along with the the version tag or the commit SHA, that is being referenced. So using our platform, you can discover all the workflows where this action was being used. And in addition, uh, over the weekend, we also added a feature where for these workflows, we actually analyze the workflow logs automatically to discover if you have leak secrets in your workflow logs. So now it shows up as a control on the dashboard, and if you click on this control, you can see all the failed instances. That is, all the workflows where we have leaked credentials due to this incident. And we also provide then links to these rather deep links to these leak secrets. So you can click on the failed runs column, and it will take you to the exact line in your workflow logs where the platform observed the leak secret. And in addition, if you are using hardened runner, because this is the malicious endpoint that was called during the attack, you can review your hardened runner findings. So in hardened runner, we provide an organizational view of all the endpoints that are being called, from your entire GitHub organization. So you can actually go to that view, type in this endpoint, and then you can look at all the runs that have called this endpoint, which is essentially like an indicator of this malicious activity, that those workflows may have used the compromised TJ actions, change files action, and may have like leak secrets in their build logs. And the last one, as we've already covered, and we also released a secure drop-in replacement for TJ actions, change files action. That is freely available to everyone. I think
Yeah,
that's pretty much
I
all I had.
yeah. So I just wanted to add here that this enterprise tier, basically you can use it, right? So you don't have to do any kind of sign up. It's just a GitHub app that you can install and you can use it to help you recover from the incident. You don't have to, buy it. It has a 14-day free trial, and if it helps you with this incident, just feel free to install it and use it. Because you should be able to figure this out, these leaks and everything, within that 14-day time.
Yeah.
I have a question on detection of this behavior. because it was coming from a jest, this was flagged as anomalous. But let's say if you're pulling it from directly from GitHub or cloning a repo, would this have been detected?
So
I can,
yeah, go ahead, Ashish.
go ahead, Varun. You go ahead.
Yeah, so I think I think the question is that since this domain was a different domain which was not in the baseline, it got detected. But what if it was downloaded from github.com, which is already part of the baseline? And so one of the features that Harden Runner has is that it can also monitor for the essentially GitHub API calls. So it could look into what are the API calls that are being made from what is the method and what is the path, and does this using eBPF. And so we also have detections based on that, to see what are the calls made. For example, one of the detection is that if someone is trying to exfiltrate something to their own organization, then the path would be different from the organization where that workflow is being run. And so it would detect it. And so, in the case of downloading, of course, it would not, it would be a get call. But to answer your question, we do have detections based on monitoring the path and the verb. We do look at or essentially Harden Runner does look at the API calls that go to github.com and api.github.com. Does that answer your question?
I would say partially. I mean, checkout, if you're doing actions checkout, it's pretty much same as cloning a repo. So the calls for both of them would be pretty much same. So I was saying like
Yeah.
we'll be blocking our checkout action as well.
Yeah, the call would be the same in the sense, the checkout typically would happen from your own repo, but in this case, it would show that it's happening from a different org.
I see. Okay.
Yeah, because the path of that call would be monitored, and so it would be checking out code from a different org.
Okay, makes sense.
So let's see if we can, go through all of the questions and okay, I think this one is done. How was the attacker harvesting the secret from the logs? So obviously we are not sure how exactly the attacker was harvesting the secrets from the logs, but what we know is that a lot of public repositories do have these secrets in their logs, and part of what we are doing is to actually reach out to them and inform them about it. Uh, the good thing is that the attacker was not exfiltrating them, and so essentially the private repositories, their secrets should not immediately go to the attacker. So that should answer that question. There was another question, can you post the curl command made by the threat actor? So that's been posted. It's also on the blog post. There's a question about StepSecurity's commitment to maintaining the action, which we've already discussed in detail. And trying to see. Is it safe to assume that the Python script dumps only those secrets that were loaded into the runner memory? So unless some secret is not explicitly accessed in the workflow file, by default, only GitHub tokens. So that's right. The script only dumps stuff from the runner memory. But in this case, if someone was using a self-hosted persistent runner, then potentially it could have more access to more credentials. But if you're using a ephemeral runner with a single job run on that runner, then yes, only the secrets that which were referred in that workflow file would be logged. The initial reports and the CB state all versions of tags were vulnerable. The TJ action teams only updated 45 tags. Can you state the tag versions that were impacted? Ashish, can you take this? There is a script which gives this information.
Yeah, so you can actually run this command. That's how we discovered all the tags and where those tags are pointing. So a quick way to verify this is we run this command and see if we have any tags that are still pointing to this commit. I mean, we have not done that analysis, but this is how we can verify that all the tags have recovered.
Actually, do you have the gist from Steve? Because I think that may have had the output as well.
Yeah, let me see. I can find that gist. Um, I'm trying to find the gist.
Yeah, I think I got it. Let me just post it here.
Oh, I found it.
Yeah, it's this one. So this gist, has the output, I believe, and so this should be it should be possible to just look at all the tags that were
Yeah.
modified. I think we can update our blog post to mention, to have this link.
Yeah.
So I think we have, covered all the questions that were on chat, but in case we missed anything, or if you have any more questions, please let us know. Okay, so looks like there are no more questions, so we can go ahead and close the call. And thank you everyone for joining and for your questions. We'll post the recording of this on the blog.
Thanks, guys. Thanks for your hard work. That was great.
Thank you.
Yeah, great job,
Thank you, everyone.
Varun,
Thanks, Ashish.
Ashish.
Bye.
Thanks, Jason.